let me say something that might offend half the internet. Most quartz veins are not gold veins. I know that hurts, because the moment you see a bright white quartz vein cutting through darker rock, your brain automatically goes, "This is it. This is where the gold is." And then you spend an hour chipping quartz like you're in a mining movie, only to end up carrying home a bag of pretty rock. I've done it too. Quartz has this effect on people. It looks clean. It looks special. It looks like the earth is highlighting something on purpose. But here's the truth. Quartz is common. Gold is not. So in this video, I'm going to break down a simple question that saves you a lot of wasted time. Which quartz veins actually signal a gold system? And which ones are just quartz? By the end, you'll understand why quartz forms, what clues matter more than the quartz itself, and how to judge a vein based on evidence, structure, alteration, and minerals, so you stop guessing and start thinking clearly. All right, let's start with the mindset shift that changes everything. Quartz doesn't automatically mean gold. Quartz means fluids were here. A quartz vein is basically a footprint of ancient fluid movement. Hot fluids moved through cracks in rock. As conditions changed, silica dropped out of the fluid and filled those fractures, forming quartz. So when you see a quartz vein, what you're really seeing is, at some point, a fracture opened here and fluids passed through it. That matters. But it's not enough, because those fluids might have carried only silica, or they might have carried silica, plus a metal-rich package that could include gold. Quartz is the record of fluid flow, not the guarantee of gold. And this is where most people go wrong. The beginner mistake is judging a vein by how white and clean it looks. People love milky white quartz. It's bright, it stands out, and it feels like a sign. But ironically, super clean quartz can sometimes mean the fluid was mostly silica-rich and not strongly mineralized. Meanwhile, quartz that looks ugly, stained, rusty, fractured, mixed with other minerals, can be closer to mineralized systems. So here's the principle I follow. Don't chase pretty quartz. Chase the evidence around it. Quartz is the stage. The clues are the actors. If gold is present, it usually isn't shouting. It's hiding inside the details. So what makes a quartz vein actually interesting? I like to judge it using 3 layers of evidence: structure, alteration, minerals. If a vein has all 3 working together, it's worth serious attention. If it's just a random white stripe with no other signs, it might be nothing. Let's break that down. First, structure. The vein is not the target. The system is. Gold deposits love structure. Faults, shear zones, fracture networks, places where rock has been stressed, cracked, and recracked. Those are the highways that fluids use over and over again. So a tiny isolated quartz vein might be meaningless, but a vein system inside a major structural zone? That's a completely different story. Here are structural situations that should make you pay attention. A vein that sits in or near a fault zone. A vein that occurs in a shear zone where the rock looks stretched or smeared. Multiple veins forming a network. Sheeted veins, stockwork patterns, ladder-like veins. Veins that repeat along a consistent direction, like the rock was cracked in an organized way. Areas where the rock looks broken and healed repeatedly. Repeated cracking means repeated fluid flow. Repeated fluid flow is how mineralization becomes concentrated. So don't just stare at one vein, zoom out. Ask, is this a one-off vein or part of a bigger system? Now the second layer, alteration. This is the part people ignore because they're hypnotized by the quartz. But in mineral systems, the rock around the vein often changes chemically. That's called alteration, and it's one of the strongest clues you can get in the field. Alteration can show up as iron staining, rusty halos around veins, bleaching, lighter-colored altered rock, clay-rich zones, soft, crumbly material that feels different from fresh rock. silicification, hard, glassy, quartz-rich wall rock, or just a clear change in the host rock texture and color near the vein. Alteration is the rock saying, something happened here. If you see a quartz vein with no alteration at all, no color change, no halo, no chemical-looking effect, sometimes it's simply a silica fill. But if the wall rock looks stained, cooked, softened, or chemically changed, that's stronger evidence the fluids were doing more than just dropping quartz. Now the third layer, minerals. This is where people get excited, sometimes too excited. Gold often travels with other minerals in hydrothermal systems, especially sulfides. Not always, but often. So quartz associated with sulfides can be a meaningful clue. Sulfides can include minerals like pyrite, arsenopyrite, chalcopyrite, galena, sphalerite, metallic grains that suggest the system carried metals. But here's the important part. Seeing sulfides doesn't automatically mean gold. It means potential. It means the fluids were capable of transporting metals. That's a higher quality clue than white quartz. But it's still not proof. Proof comes from testing and patterns. And there's another twist. When sulfides oxidize, they often leave iron oxides, rusty staining, reddish-brown colors, and ugly rock surfaces. That's why rusty ground and ugly rocks show up so often in real gold discussions. Oxidation doesn't create gold, but it can reveal that mineralization existed. So at this point, here's the takeaway. Quartz alone is not enough. A good target is quartz plus structure, plus alteration, plus mineral clues. And there's one more detail that matters a lot: vein texture. Some veins are simple, massive quartz with very little going on. Others show signs of repeated events: broken and re-cemented quartz, banding, cavities, iron-stained fractures, or oxidized boxwork textures where sulfides used to be. Those textures can hint at how dynamic the system was. And more dynamic systems can be more interesting because repeated fluid events can concentrate minerals more effectively. So in the next part, I'll explain how to read quartz vein textures, how to spot the difference between low-priority quartz and gold system quartz, and how to use simple field logic to test smarter without getting fooled by shiny distractions. All right, let's continue. If part 1 was the mindset shift, quartz doesn't automatically mean gold, then part 2 is the practical question. How do you tell quartz that matters from quartz that wastes your time? Because the truth is, the Earth can produce quartz veins in all kinds of situations. Some are totally harmless, some are part of mineralized systems. And a lot of people get stuck because they look at the vein, not the context. So in this part, I'm going to give you a simple way to judge a quartz vein using clues you can actually see in the field. Not a lab, not a fancy report, just real-world evidence. The key idea is this: a gold system quartz vein usually comes with a package: structure, alteration, mineral clues, texture. If the package is missing, the vein is low priority. Now let's go step by step. First, stop staring at the brightest part of the quartz. Quartz itself is often the least interesting part. What you want is what's happening around it. 1. Start with the host. Rock. Does it look normal or changed? Walk up to the vein and look at the rock on both sides. Ask yourself, does the host rock look the same everywhere? Or does it look chemically different near the vein? Because fluids don't just fill a crack, they interact with the wall rock. If the wall rock looks unchanged, same color, same hardness, same texture, sometimes that suggests a simple silica fill. But if you see a halo of change around the vein, now you're in more interesting territory. Look for iron staining, rusty reds, oranges, browns spreading into the rock, bleaching, areas that look washed out or lighter than the surrounding rock, clay alteration, rock that turns softer, crumbly, or dirty compared to fresh rock, Silicification, rock that becomes unusually hard, glassy, or quartz-rich near the vein. This doesn't prove gold, but it proves something happened. And in geology, something happened is the beginning of everything. 2. Look for ugly features. Broken, rusty, and messy can be good. This is where people get it backwards. They find a clean vein and get excited, but clean can mean simple. Meanwhile, the veins that look ugly, fractured, stained, mixed with other minerals, can be closer to mineralization. So pay attention to quartz that's cracked and re-cemented, quartz with rusty fracture lines, quartz that looks like it went through stress and got healed again, quartz mixed with darker minerals, not just pure white. Because mineralized systems often involve repeated events: crack, fluid, seal, crack again, fluid again. And repeated events are how minerals concentrate. 3. Vein texture. What the quartz surface is telling you now. Let's talk texture, because this is a quick field filter. There are a few vein textures that are commonly more interesting. Banded quartz, layers or stripes like the vein formed in pulses. Brecciated quartz, broken fragments cemented together, showing violent movement. Vuggy quartz, small cavities or open spaces, fluids had room to move. Iron-stained boxwork, honeycomb-like textures where sulfides oxidized away. These textures suggest the system had movement, pressure changes, multiple pulses. Again, not proof of gold, but higher potential than a simple massive vein with no story. Massive milky quartz can still host gold sometimes, but if it's massive, uniform, and clean with no other indicators, it's often lower priority. 4. Sulfides and oxidation, the mineral clues. That actually matter. Gold is often associated with sulfides in hydrothermal systems. So you want to look for evidence of sulfides, either still present or oxidized away. Fresh sulfides can look metallic, brassy silver gray, or dark metallic grains inside quartz or in the wall rock. But many times, sulfides are gone on the surface because they oxidize. So what do they leave behind? Rust, iron oxides, stains, sometimes a crumbly Gaussian look, sometimes cavities where sulfides used to be. So if you see quartz plus strong iron staining, especially in a halo around the vein, that's a meaningful clue. But remember, rust alone isn't gold. Rust is the smoke. Gold might be the fire, or it might not. Your job is to stack clues. 5. Structure check. Is this vein part of a system? This part is huge. A single isolated vein can be nothing, but a vein that sits in a structural zone can matter. So step back and scan the area. Ask, are there multiple veins with the same orientation? Do you see a network of veins, sheeted veins, or stockwork? Does the rock look sheared or foliated, like it's been squeezed and stretched? Do you see crushed zones, broken rock, or a fault gouge-like texture nearby? Gold systems often sit in places where rock movement created pathways for fluids. If the area looks like it's been repeatedly stressed and cracked, your odds improve. If it's just one random vein cutting stable rock with no other signs, odds drop. 6. The priority score. Method: simple field logic. Here's a quick way to think about it. Low priority quartz, clean, massive, isolated, no alteration halo, no sulfide signs, no structure. Medium priority quartz, some alteration or staining, some fracturing, maybe a few related veins nearby. High priority quartz, clear structure zone, multiple veins or vein network, strong alteration halo, sulfide evidence or oxidation textures, broken and re-cemented quartz, consistent pattern across the outcrop. You're not claiming gold, you're ranking targets. That mindset saves you time and keeps you realistic. 7. A quick reality check before you get emotionally attached. Here's the trap I see all the time. People find a vein, fall in love with it, and then spend hours trying to prove it's gold. Don't do that. Use the vein to ask better questions. If the clues stack up, test it. If the clues don't stack up, move on. Because the Earth will always offer you quartz. Quartz is unlimited. Your time is not. So in the next part, I'll go into the most common lookalikes and mistakes, why people confuse mica, pyrite, and iron stains as proof, and I'll explain simple field tests and observation rules that keep you from getting fooled. Now we're going to talk about the part that ruins people emotionally, the shiny traps, because this is what happens in real life. You find a quartz vein, you see sparkle, your brain lights up, your heart rate increases, you start imagining thumbnails, and then it's mica, or it's pyrite, or it's just iron staining playing tricks in sunlight. So in this part, I'm going to walk you through the most common things that fool people when they're reading quartz veins and gold indicators, and how to stay calm and test intelligently. The goal is not to kill your excitement. The goal is to stop you from being manipulated by light reflections, because nature is basically a professional illusionist. First, the biggest liar, mica. Mica is everywhere. And mica loves attention. It breaks into thin, reflective flakes, and under sunlight, it can sparkle like crazy, especially in quartz-rich areas. Here's why mica fools beginners. Gold is yellow and shiny. Mica is shiny and sometimes looks yellowish. So your brain connects two dots that don't belong together. But mica behaves differently than gold. Gold is heavy. It settles fast and stays put. Mica is light. It floats, flutters, and spreads out. So if your gold looks like glitter scattered everywhere, dancing around in water, flashing at every angle, that's mica. Real gold in a pan tends to collect with the heavies and sit low. It doesn't float around like it's trying to impress you. Also, mica often appears as lots of tiny sparkles across the surface of the material. Gold usually appears as distinct pieces, flakes, dots, or small flat bits that stay where the heavy material sits. The second liar is the famous one, pyrite. Pyrite is called fool's gold for a reason. It can be brassy yellow, metallic, and it often occurs in the same kinds of hydrothermal systems that form quartz veins. So pyrite can actually be a clue that the system carried metals. But pyrite is not gold. Here's the simple difference. Gold is malleable. Pyrite is brittle. Gold bends and flattens. Pyrite cracks and breaks. Now, in the field, you don't always want to smash everything, but the key is, don't treat pyrite like a jackpot. Treat it like information. Pyrite says, there was a metal-bearing fluid system here. That's useful, but it's not a payday by itself. And here's something important. Pyrite often oxidizes. When pyrite oxidizes, it can leave rusty stains, crumbly material, and sometimes holes or cavities where sulfides used to be. Which brings us to the third trap, rust. Rust is not gold. Rust is not proof. Rust is a sign that iron-bearing minerals reacted with oxygen and water. So when people say rusty ground means gold, what they really mean is rusty ground can sometimes indicate mineralization. But mineralization can be many things. It can be iron-rich without gold. It can be sulfides without gold. It can be the right system, but the gold is elsewhere. It can also be a completely unrelated weathering effect. So rust is a clue, not a conclusion. The correct use of rust is, it tells you where fluids and minerals may have interacted with rock. Then you look for structure, alteration patterns, and consistent mineral associations. Now let's talk about another sneaky one, iron-stained quartz. Sometimes quartz itself gets stained yellow-brown by iron oxides, and in bright sun it can look golden. That can be a clue that sulfides existed and oxidized, but it also creates a visual illusion. So don't judge by color alone. Quartz can be stained. Gold is a separate metal. You need to stack evidence. Now let's talk about the trap that causes the most wasted time, seeing one good-looking clue and stopping your thinking. People see one thing, sparkle, rust, quartz, and their brain shuts off. They go, "This is it." But geology doesn't work with single clues. Gold systems are patterns. So the right approach is, look for multiple clues that agree with each other. Here's a simple way to keep yourself honest. The 3-question rule for any quartz vein. When you find a vein and you get excited, stop and ask these 3 questions. 1. Is there structure here? Faults, shear zones, repeated fracturing, multiple veins, consistent orientation. 2. Is there alteration? Hollows, bleaching, clay, silicification, chemical change in the wall rock. 3. Is there mineral evidence, sulfides present, or oxidation textures where sulfides used to be, plus consistent heavy mineral signs? If you only have one of these, your confidence should be low. If you have 2, it's worth testing. If you have all 3, it becomes a serious target. Now I want to add a personal note because this is real. Most people aren't fooled because they're dumb. They're fooled because the earth gives you emotional rewards before it gives you real results. Sparkle feels like success, even when it's not. So the skill is learning to separate looks exciting from is meaningful. That's what makes you consistent. Now, in the next part, we're going to get more practical. How to test a quartz vein area without a lab. How to sample intelligently. How to avoid wasting hours on the wrong spot. And how to use the surrounding landscape, float rock, scree, drainage patterns, to decide where to look next. So now you can recognize the traps: mica, pyrite, rusty staining, the shiny stuff that makes your brain light up too early. But the real question is, what do you do next when you find a quartz vein that looks promising? Because you can stand there staring at it all day and nothing changes. Quartz doesn't magically become gold because you believed in it harder. So in this part, I'm going to explain a simple, practical way to test a quartz vein area in the field, using a method that keeps you logical, not emotional, and definitely not, "I'm going to dig here for 3 hours because it feels special." The mindset is this: you're not trying to prove a vein is gold on the spot. You're trying to answer one question: is this part of a mineralized system worth spending more time on? That's it. So here's the process I use. First, don't start by breaking the prettiest quartz. Start by looking for the system around it. Step back, scan the area. Ask yourself, where is the structure? Where is the broken zone? Where is the alteration strongest? Where do multiple veins show up? Because if gold is involved, it's often not evenly spread through one clean stripe of quartz. It's associated with the structural zone that carried fluids and the zones where fluids interacted with wall rock. So the first test is actually observation. Look for a consistent pattern. Do you see several veins aligned the same way? Do you see a shear zone where rock looks crushed or stretched? Do you see a line of rusty staining that continues beyond a single outcrop? Do you see the same altered rock texture repeating along a trend? If the answer is yes, now you're thinking correctly. System first, vein second. Now here's a simple technique that stops you from wasting time. Follow the rock fragments, what people call float. Float is loose rock that has broken off from somewhere upslope and moved downhill, usually by gravity and erosion. And in many places, float is your free sampling system. If there's mineralized quartz higher up, pieces often end up scattered downslope. So instead of spending all day hammering one outcrop, look around the slope below it. Do you see quartz fragments mixed into the soil? Do those fragments show iron staining? Do they show sulfide cavities or boxwork texture? Do you see multiple pieces with similar features? If the float is abundant and shows the same package of clues, that's a strong sign the system isn't just a one-off vein. Now, when you do take samples, The goal is not to take random pieces. Most people grab the whitest quartz and call it a sample. But if quartz is just the container, you want the parts where the interesting stuff concentrates. So, when collecting a small sample, target fracture zones in the quartz, especially where iron staining is concentrated. Contacts between quartz and wall rock, where fluids interacted most. Brecciated sections, broken and re-cemented areas. Areas with visible sulfide grains, or cavities where sulfides oxidized away. Altered wall rock itself, especially if it's rusty, softened, or chemically changed. That's where the story is. Clean, massive quartz with no texture is often just silica. The messy zones are where systems leave clues. Now, let's talk about the big mistake people make when they test a vein. They test only one point. They take one sample from one spot and mentally declare victory or defeat. That's not how geology works. A mineral system is not uniform. It's patchy. It has hotspots and dead zones. So you want to test along the trend. If you suspect a vein or shear zone runs in a certain direction, you test multiple points. One point near the strongest alteration. One point a little up the trend. One point a little down the trend. And if possible, one point across the zone. You're not looking for perfection. You're looking for consistency. If the alteration and mineral signs repeat along the zone, that's meaningful. If everything disappears after 5 meters, it might be a small, low-potential feature. Now, this is where people ask, but how do I know where gold is without lab equipment? You don't. Not with certainty. But you can get very good at identifying whether you're in the right kind of system. And in practice, that's what saves you time. Because once you can recognize a metal-bearing hydrothermal system, you stop chasing random quartz and start following structures and altered zones. That's where real targets usually are. Now let me add a practical reality check. Just because a system is mineralized doesn't mean the gold is economic or even present in visible amounts. Gold can be microscopic. It can be locked in sulfides. It can be present in tiny quantities. So your field goal is not, I need to see visible gold. Your field goal is, does this look like a gold-capable system? That's a totally different mindset, and it stops you from falling into the most common trap: emotional attachment to one pretty vein. Now, there's one more field clue that's surprisingly useful: the landscape pattern. Look at how quartz shows up across the area. Is it only at one outcrop? Or do you see scattered quartz, multiple outcrops, and repeated alteration along the ridge? Does the drainage cut through the altered zone? Are there gullies where material is actively eroding out? Because if there's a mineralized zone, erosion will move fragments into drainages, and drainages can help you find where the system is exposed. This doesn't mean you instantly start panning streams. It means you use the drainage as a map of what's eroding from upstream. So the whole method is simple. Observe the structure and alteration pattern. Check float downslope for repeated clues. Sample the interesting zones, not the prettiest quartz. Test along the trend, not just one point. Use landscape and drainage to understand where material is coming from. That's how you stay logical. And when you stay logical, you stop wasting whole days on quartz that only looks exciting. When you start looking at quartz veins the right way, you stop thinking in single lines of white rock and you start thinking in zones. Because in real gold systems, gold usually isn't spread evenly through the quartz, like chocolate chips in a cookie. It's concentrated where the system had the right conditions: structure, repeated fluid flow, and chemical reactions that helped metals drop out and stay. So in this part, I want to answer the practical question that comes after testing and observing. If a quartz system is mineralized, where does the gold tend to concentrate? And why? Let's begin with the simplest truth. Gold likes repeat activity. A single crack that opened once and filled with quartz might produce a clean, simple vein, but it often doesn't produce much metal concentration. The systems that build real mineralization are the ones that cracked, moved, and healed repeatedly over time. Every time the rock opens, fluids move. Every time fluids move, minerals have another chance to deposit. That repetition is what builds hotspots. So instead of asking, "Is this a quartz vein?" ask, "Does this vein show repeated events?" And this is where texture and structure connect. Brecciated quartz, broken fragments cemented back together, often means movement happened more than once. Banded quartz can mean multiple pulses of fluid. Vein networks and sheeted veins suggest a fracture system that kept reopening. Those patterns don't guarantee gold, but they tell you the system was active enough to concentrate something. Now let's talk about the second truth. Gold likes edges, not just the middle. A lot of people focus only on the quartz. But in many hydrothermal systems, the strongest reactions happen at the contact between the quartz and the wall rock. That's where hot fluids meet a different chemistry, where minerals can precipitate, and where alteration halos develop. So one of the most common places for gold-associated minerals is not in the clean white center, it's in the messy boundary zones. That means the most interesting parts are often the quartz wall rock contact, fracture zones cutting through quartz, brecciated sections where new fluid pathways formed, and altered wall rock near the vein. If you only chase clean quartz, you can miss the zones where the system actually deposited metals. Now, the third truth. Gold likes structure that focuses flow. Not all fractures are equal. A random crack might carry a little fluid once, but faults and shear zones can act like long-lived plumbing systems. They create pathways, permeability, and repeated openings. They also create places where the flow slows down, changes direction, or reacts strongly with rock, all of which can cause minerals to drop out. Inside a shear zone or fault zone, gold commonly concentrates in bends in the structure, where stress created more fracturing. Intersections where two structures meet, creating extra pathways. Zones of dilation, places that opened slightly more and allowed more fluid movement. And areas where the rock is repeatedly brecciated and healed. Think of the system like a highway network. The main road matters, but the traffic jams and intersections are where things pile up. That's where concentration happens. Now let's connect this to what you can actually see on the surface. Oxidation can hide gold, but it can also reveal the system. When sulfides are present, minerals like pyrite and others, they often oxidize near the surface. That oxidation creates rusty staining, crumbly textures, and sometimes cavities where sulfides used to be. The rust itself isn't gold, but it tells you the system had sulfides, meaning it was moving metals. So in many cases, the most gold-capable zones look ugly. Rusty halos around veins, dark, iron-stained fractures, quartz with oxidized boxwork texture, altered rock that looks bleached or softened, broken zones that look messy and disturbed. Those ugly zones often mark the parts of the system that actually had chemistry and permeability. Two things gold needs, but there's an important warning here. Oxidation can also scatter the evidence. At the surface, sulfides can break down and wash away. Iron staining can spread. The original mineral textures can be partially destroyed, so surface appearance can be misleading if you treat it like proof. This is why you always stack evidence. If you see rust, but no structure pattern, no vein network, and no alteration beyond a random stain, your confidence should be low. But if you see rust, plus strong alteration halos, plus a clear structural zone, plus repeated vein textures, now you're seeing a coherent story. And a coherent story is what makes a target worth your time. Now let me summarize this in a simple way you can carry into the field. When you're trying to locate the hot parts of a quartz system, you prioritize zones with repeated fracturing and healed textures, vein networks rather than isolated veins, contacts and boundary zones rather than clean quartz centers, structural intersections, bends and dilation zones, strong alteration halos, and consistent oxidation patterns that repeat along a trend. That's the core logic. You're not hunting a single vein. You're hunting the places where the system focused fluids, repeated activity, and chemical reactions. And once you start thinking like that, you stop being fooled by one pretty outcrop. You start reading the system. After you understand where gold tends to concentrate inside quartz systems, the next problem is simple. You still have limited time in the field. You can't chase every vein. Quartz is everywhere, so you need a decision method, something that keeps you moving toward better targets instead of getting stuck on the first thing that looks interesting. This part is that method. It's not complicated. It's basically a way to rank what you're seeing using the same evidence we've been building the whole time: structure, alteration, minerals, and texture. The difference now is you'll use those clues to make clear decisions: low priority, medium priority, high priority. First, here's the rule that keeps everything honest. Never rank a quartz vein by quartz alone. Rank the vein by the system around it. So when you arrive at a quartz area, you do 3 fast checks in this order. Check 1. Is there a real structural zone here? You're looking for signs that rock movement created long-lived pathways. A fault zone, a shear zone, crushed or broken rock, consistent fracture direction, multiple veins repeating, a vein network rather than a single stripe. If structure is weak or random, the target is usually weaker. If structure is strong and organized, your target quality increases immediately. Structure is the plumbing. Without plumbing, fluids don't move repeatedly, and without repeated flow, you rarely get strong concentration. So if you see one isolated vein with no network, no repeated pattern, and no sign of deformation around it, that usually starts in the low category. If you see multiple veins, repeating orientations, and a zone of fractured or sheared rock, you're moving into a more serious category. Check 2. Is there alteration that makes sense and repeats? This is where you confirm the system actually interacted with the host rock. You want alteration halos that look consistent along the zone. Iron staining that follows the same trend as the veins, not random patches. Bleaching or chemical-looking change around the structure. Clay-softened zones or decomposed wall rock near the vein. Hard silicified wall rock that extends beyond a single point. The key word is repeat. One stain can be nothing. A repeating alteration pattern along a structural trend is information. If alteration is absent, or only shows up as a tiny random patch, your confidence should stay low. If alteration is strong, continuous, and clearly connected to the structure, your confidence rises. Check 3. Is there mineral evidence or oxidation textures that match the story? You are not chasing sparkle. You are looking for metal-bearing signals. Fresh sulfides can be a clue. Oxidized sulfide textures can also be a clue. Rusty fractures, boxwork cavities, Gaussian-like zones. These suggest the system carried minerals that later reacted at the surface. Again, one shiny grain doesn't mean anything on its own. What matters is whether mineral evidence matches the structure and alteration pattern. If you have structure and alteration, but zero mineral evidence anywhere, no sulfides, no oxidation textures, no consistent iron oxide patterns, then you keep it in the medium category until more evidence appears. If mineral evidence is present and consistent with the zone, that's when the target becomes high priority. Now here's how you put this together quickly. The priority ranking, simple and honest. Low priority targets usually look like this. One clean massive quartz vein, no vein network, no obvious structural zone, no alteration halo, no sulfide or oxidation textures. Everything looks pretty but chemically quiet. This doesn't mean it's impossible. it means it's not worth heavy investment compared to better targets. Medium priority targets usually look like this. Some structure, maybe a small fracture zone or a few parallel veins. Some alteration, light staining, partial bleaching, minor clay. Some texture, fractures, slight brecciation, uneven zones. But the evidence is not strong or not consistent yet. These targets deserve sampling and checking along the trend, but you stay realistic. High priority targets usually look like this: a clear fault or shear zone, crushed or deformed host rock, multiple veins or a vein network that repeats, strong alteration halos that extend and follow the structure, sulfide evidence or oxidation textures that appear repeatedly, quartz textures that suggest repeated events, brecciation, banding, healed fractures. This is where you invest time because the whole package is present. Now, here's the decision rule that keeps you from wasting hours. If you cannot stack at least 2 strong lines of evidence, structure plus alteration, or structure plus minerals, or alteration plus minerals, you do not stay long. You test, you observe, and you move, because the earth will always tempt you with almost interesting. Quartz areas love being almost interesting. Now let's address one more trap: emotional commitment. A lot of people find a target, get attached, and then try to force the story to fit. They start interpreting every little stain as proof, every sparkle as gold, every crack as a major fault zone. That mindset burns time, so use the method like a filter. If the system doesn't show the package, you don't argue with it. You just rank it lower and move. And if the system does show the package, you don't assume success either. You stay calm and test along the trend, because even high priority zones can be patchy. At this point, you now have a full logic chain. Quartz means fluids. Structure tells you where fluids could travel repeatedly. Alteration tells you fluids reacted with rock. Minerals and oxidation textures tell you the system carried metals. Textures and repeated patterns tell you where concentration is more likely. That's the complete decision framework. So now you have the full picture. Quartz on its own doesn't mean gold. It means fluids moved through rock. That's the starting point, not the conclusion. The mistake is stopping there, getting hypnotized by white quartz and assuming you found something special. What actually matters is the system around the quartz. If you remember nothing else from this video, remember this: you're not hunting a quartz vein, you're hunting a mineralized system. And mineralized systems leave a package of evidence. The strongest targets are the ones where that evidence agrees with itself. Here are the rules I personally keep in my head in the field. First rule: structure comes first. Faults, shear zones, repeated fracturing, vein networks. This is the plumbing. Without plumbing, fluids don't move repeatedly, and without repeated flow, you rarely get meaningful concentration. Second rule: alteration is the next check. If the wall rock around the vein looks chemically changed, rusty halos, bleaching, clay-softened zones, silicification, that's the rock showing you fluid interaction. Clean quartz with no alteration is often low priority. Third rule: minerals and oxidation textures are the proof of a metal-bearing system. Fresh sulfides are a clue. Rusty fracture zones, boxwork cavities, Gaussian-like textures are also clues. They don't guarantee gold, but they confirm the system carried minerals worth reacting and breaking down. Fourth rule: texture tells you whether the system was active enough to build hotspots. Banded quartz, brecciation, healed fractures, vein networks. These suggest repeated events. Repeated events are how a system concentrates metals instead of spreading them thin. And here's the simple decision filter that ties everything together. If you can't stack at least 2 strong lines of evidence, structure plus alteration, structure plus mineral evidence, or alteration plus mineral evidence, you don't spend long there. You test, you learn, and you move on. because quartz is endless. Your time is not. Now, the biggest mental trap in quartz hunting is emotional attachment. People find a vein, fall in love with it, and then try to force the story to fit. They start treating sparkle as proof, rust as proof, one good-looking rock as proof. But geology doesn't run on single clues. It runs on patterns. So the right way to do this is to stay calm and let the evidence build a consistent story. If the structure repeats, the alteration repeats, and the mineral signs repeat along the same trend, that's when a target becomes serious. That's when you invest time, not because you're sure there's gold, but because the system is behaving like a gold-capable system. And if the evidence doesn't repeat, you don't argue with it. You rank it lower and move. That's how you stop wasting days. That's the mindset that changed everything for me. Stop chasing the prettiest quartz and start chasing the strongest evidence. Once you do that, you'll still get surprised sometimes because nature is never perfectly predictable. But you'll stop being lost. You'll stop guessing. You'll start making decisions with clear reasons. And when you finally do hit a zone that has the full package, structure, alteration, metal clues, active textures, you'll know exactly why it matters. Not because it looks exciting, because it makes sense.